2020 is an election year, so we can expect to hear lots of talking points that make one candidate look good and the other candidate look bad. You'll look at social media or turn on the news and hear about the murder crisis threatening Americans. And then you turn the channel and hear about record drops in homicide rates. How do we know which claims are accurate and which are misleading? Well, some claims will be supported by evidence in the form of statistics. But what if that evidence can also be used to mislead? Or as it has been attributed to Mark Twain, there are three kinds of lies: lies, damned lies, and statistics. Of course, in the age of social media and the internet, a fourth kind of lies are facts on the internet, as Mark Twain himself attributed a quote to British Prime Minister Benjamin Disraeli. In this video, we will look at what are statistics. Not the scary statistics you learn in school, but how we can look at numbers used as evidence. Why are statistics needed? And finally, how do different statistics, often from the same collection of data, support very different conclusions? Stick around to the end of this video when we consider how can statistics be used to prove a point without misleading. So what are statistics? Statistics are mathematical models that concisely and hopefully accurately summarize a set of observations or data. In this graph, we see the daily high and low temperatures in Philadelphia for May and June 2024. Sometimes the days and nights are hotter, and sometimes they're colder. But how can we explain the change in temperature as we go into summer? This graph uses a form of statistics, an average. The average high in red and low temperature in blue, using all of the temperatures in their database. This smooths out the daily variation and shows, not surprisingly, that the temperature in Philadelphia gets hotter as we go from May into June. The average is a form of statistics used in describing numbers or observations. A second type of statistics is used to make comparisons to determine if something is better or worse than something else. This type of statistics uses more complicated mathematical formulas, but it is important to science and the Food and Drug Administration to determine if a new medication is better than something already available. We started this video by talking about crime statistics, more specifically, murders and homicides. Many people are uncomfortable looking at numbers, so statistics are often presented in the form of infographics. This image shows the total number of homicides by state in 2020. The darker colors indicate higher numbers of murders, so we see California and Texas with the most, followed by Illinois and Florida, with New York, which is discussed a lot in the news, coming in at number 10. Is this an accurate representation of the data? Many people argue that the total number of murders is misleading, since some states have larger populations than others. In this infographic, instead of total numbers of murders, the data presented is the total number of murders for every 100,000 residents. In this per capita image, Mississippi and Louisiana have the most murders at over 20 murders in 2020 for every 100,000 residents. Texas comes in at number 20, Florida at number 22, California at number 26, and New York at number 23, with less than 5 murders per 100,000 residents. The data presented in both of these images is correct, but they show very different messages. Which is the most accurate way to show murders in America? There's a lot of conflicting information in the news and on social media, so I wanted to look at the numbers myself to present the information as directly as possible to you. I downloaded homicide data from the Centers for Disease Control database because they are required to record the cause of death listed on a death certificate. This is important since police departments are only encouraged to report murders to crime databases, such as the one managed by the FBI, so their information may be incomplete. This collection of data was over 1,100 lines long and has been scrolling on the screen. We need statistics to describe the data so that you don't have to look at each number individually. This also highlights one important thing to consider when hearing claims supported by statistics. Where is the data coming from? and how complete and accurate is it? I created these graphs using the data from the CDC. Along the x-axis down here are going to be years running from 1999 to 2020. And along the y-axis, kind of going up and down over here, is going to be the total number of homicide deaths. And so what we can see is that in light blue is New York, in orange is Florida, in red is Texas, and California is up here at the top in dark blue. If we take a look at this, the one thing that stands out is this huge number of deaths that occurred in New York in 2001. If we think about that, that is representing the deaths that are associated with 9/11. Is this an appropriate way to present the data? Many people would argue that the deaths associated with 9/11 are an act of war rather than true homicides. And so what I've done in this graph is removed the 2001 9/11 deaths, and so what we end up with is going to be an average kind of going through from 1999, 2000, 2001 in this range here. If we take a look at this, we can see that New York in light blue and Florida in orange are about the same from 1999 to about 2005, 2006. But from that point on, homicide rates in New York, or homicide totals in New York have declined, at least up until 2020, while in Florida, those numbers have increased. Often when we see data presented in the form of graphs on social media or in the news, instead of individual years, like we've got in this graph, we're going to take a look at 4-year intervals that correspond to presidential terms. And so the data is going to run from 2001 to 2020, and instead of 20 data points, we're going to have 5 data points for each one of these time intervals. Again, this smooths out the data and allows you to see kind of greater patterns without the variability that's occurring on an annual basis. Finally, a more accurate way to present this data and have it be used by scientists and mathematicians is to add an error bar. And this error bar represents the standard deviation, which, to kind of oversimplify it a little bit, just gives you an idea about how much variability there is in the measurements, or in this case, the homicides, from year to year. As we illustrated with the infographic earlier in this video, we can take a look at total homicides over here on the left and compare it with per capita homicides. And so this is the total number of homicides divided by 100,000 residents. What we can see is in total homicides, we've got California up here, again, because they have a much larger population, with a much higher number of homicide deaths. However, if we take that number of deaths and divide it by the number of residents, in this case 100,000 residents, what we can see is that California is kind of more in line with what we see with Texas in red and Florida in orange. A little bit a difference as we go through, but it's not an outlier as we see here with the total homicide deaths. Again, looking at per capita, is this a better way to show it? New York City, again, including the 9/11 deaths, is much lower than we see in both total homicides and per capita homicides than California, Florida, and Texas. Both of these graphs are accurate, but which is more representative of the results? Often when we see statistics, or at least data being presented, it's used to show how something was better or worse at one period of time in a relationship to another. And so in this case, we've gone back to the per capita homicide deaths. And so again, this is the total number of homicide deaths reported on death certificates to the Centers for Disease Control divided by 100,000 residents. And so it kind of normalizes it based on the size of the state that's involved. In this case, if we take a look at just the values from 2013, 2016, and 2017 to 2020, we could come up, again, looking within this block, with a statement that says, since 2013 to 2016, homicide deaths have increased in Texas and Florida and remained level in California and New York. And again, that's by looking at just the values within this box. If we extend the box a little bit further, going back to 2009 to 2012, and making a comparison of the 2009-2012 numbers in relationship to 2017 to 2020, we could come up with the statement, since 2009 to 12, homicide deaths per capita have increased in Texas and Florida and decreased in California and New York. If we expand the box a little bit further to include another presidential term, we can take a look at the values from 2005 to 2008, compare them with the values of 2017 to 2020, and come up with the statement, since 2005 to 2008, homicide deaths per capita have remained level in Texas and Florida and decreased in California and New York. So to combine the analysis on the three previous slides, we could come up with a statement for Texas that says, for Texas and Florida, the per capita homicide deaths have remained level since 2005 and 2008, or we could say that they've increased since 2009, 2012, or we could say they've increased since 2013, 2016. In contrast, if we take a look at California and New York, we can say that it's decreased since 2005 to 8, it's decreased since 2009 to 12, and remained stable since 2013 to 2016. All of these statements are correct, but what is more representative of the results? So these per capita homicide graphs are showing the number of deaths per 100,000 residents within an entire state. It can be argued that that's not an accurate way to represent it because there's a higher concentration of people and presumably higher levels of crime in urban areas. And so what we've got here, the same graphs that we've been looking at over here on the left, per capita homicide deaths that reported to the CDC for the entire states of California, Florida, New York, and Texas. And over here, we've got per capita homicide deaths for Los Angeles County, California. We've got Miami-Dade County in Florida. We've got at the bottom here, Harris County in Texas. And then finally in light blue, we've got New York City. And New York is a little bit different because there's actually 5 counties that correspond to New York City. And so I've kind of broken the rules here by saying we're going to look at counties, but we're grouping together the 5 counties in the greater New York City area. And so if we take a look at this, homicides per capita by the entire state on the left-hand side, homicides per capita by most populated county in that state. And we see, kind of a slightly different pattern. In this case, we're seeing that light blue is New York, darker blue is California. Those values are dropping down below what is the most populated county in Texas and Florida. Again, both of these graphs are correct, but which is more representative of the results that we want to talk about? Another thing to keep in mind when looking at results presented with graphs is what is the actual values along the y-axis. Basically, how high are the numbers going? If we look at per capita homicide deaths on the entire state basis, over here we're going to go from 0 to 8 deaths per 100,000 residents. In contrast, if we look at the counties, the most populated counties, and again, the 5 counties of the New York City area, we see that this graph goes from 0 to 16. And so this top line up here would represent 16 deaths per 100,000 residents. So potentially a more accurate representation of this would have the same values, kind of the same height of this y-axis, the same height of this graph. And so if we make that variation, what we can see is that if we look at those urban areas, again, arguing that there are more deaths occurring in urban areas, in this case, both of these graphs are going to go from 0 to 16 homicide deaths per 100,000 residents. And we can see statewide, the values are, pretty much between 6 to 8, maybe 5.5 to 8 for the entire state. But if we take a look at it for per capita deaths in these most populated counties within each one of these states, we can see that it's ranging from 4 down here for New York City, upwards up here, 14 again is including New York with the the 9/11 deaths, but basically going up here to about 12 deaths per 100,000 residents. Again, both of the graphs were accurate with this previous graph, but this shows you a more reasonable comparison between the statewide data over here, fewer deaths attributed statewide, higher deaths within these urbanized areas. But again, a difference between New York and California in comparison to Texas in red and Florida in yellow. Again, both of these graphs are correct, but which is more representative of the results? One final thing to think about when looking at sets of data and the quality of the data that's being used to make these statements is for scientists and mathematicians, and again, using the CDC data set here, they go through and they include a series of notes that explains potential problems with this data. So in this case, we've got 2017. They adjusted some deaths within Georgia. In some cases over here, we're looking at an unusually high amount of ill-defined or unspecified causes of mortality. Doesn't affect the homicide data that we're looking at here. But it's just saying, there were these anomalies, there were these unexpected differences, and this is how it's dealt with. It also says that you need to be very careful at making conclusions if there are very few deaths within a reporting area. And they say basically don't make any decisions on policy if there are fewer than 20 deaths within a region. So all of the homicide graphs using CDC data are factually accurate, but they can be used to support different messages. There's a lot of finger pointing, especially during an election year, with Democrats claiming that lax Republican gun laws are going to drive up murder. Republicans on the other side are saying that Democratic mishandling of policing and prosecution is resulting in more murders. But the end result is we have a very serious problem that needs bipartisan attention in order to solve. But the first thing is that we need to be able to talk about it with common terms and a common understanding so that we're not using misleading statistics to prove or disprove a point. So as we consider this week's ethical dilemma in science, please leave your comments below as to how we can use statistics to prove a point without misleading. To help the thought process get started, I've got a couple prompts for you to consider. What factors should be considered in deciding how data is presented? Is it ethical to selectively present statistics to support a particular position while omitting contradictory data? And then finally, in scientific papers, researchers explain where the data came from and how they analyzed the data. Should a disclaimer be available for any statistical points so that the recipient can judge the accuracy of the statement on their own? In the description below is additional information and references. If you enjoyed this video, please like and subscribe for more conversations on the ethical impact of science and technology on society. Until next time, stay curious and be informed.